Alright, so I want to solve this rational equation. We have 4 over x minus 2 equals 5 over x plus 3. Now there's a variety of ways to solve rational equations, but in this case we notice there's one fraction on the left and one fraction on the right. Right? So in this case we can just cross multiply, right? So if we have a over b equals c over d, I'm just using a, b, and c, and d, right, just to represent the different parts of these fractions, right? Then we know that a times d, right, a times d is equal to b times c. Now remember, this idea of cross multiplying only works in this very specific case, right? There's one fraction on the left and one fraction on the right. So let's do that here, right? We get 4 times x plus 3 equals 5 times x minus 2. So by doing so, we've eliminated all the fractions, right? That's good. We should be able to solve this guy. 4x plus 12 equals 5x minus 10. I'm just going to, I guess I'll subtract the 4x to both sides here. Okay. That leaves me with 12 is equal to x minus 10. And then from here, I'm going to add the 10 so I can get the x by itself. And I should arrive at my final answer in this case, right? X is equal to 22. And that's going to be my final answer here. Now, we don't need to do this every single time, right? But you notice when you plug the 22 in here, we don't get a 0 in the denominator, and that's good, right? So we know that 22 is a good answer, right? Because, we've made no mistakes, and we don't get a 0 when we plug it back in. And now we could plug it in just to see what happens, right? Let's try it out. 4 over 22 minus 2 equals 5 over 22 plus 3. Notice what happens. This is 4 over 20, which is 1/5. And this is 5 over 25, which is also 1/5, right? So we just verified that, right, this is a good answer.